Hi, everyone. Welcome today. This is another event organized by EHPA. I'm very happy to be here. I'll be your host today. I'm Nora Ganzinelli, and I'm an EU project officer. Let's wait a few seconds because participants are joining. But as I said, very happy to be here today. So, yeah, I would say, let's start. I don't see anyone else joining as of now. As I said, I'm Nora Ganzinelli. I'm an EU project officer here at EHPA, and today I will be moderating this event. This event that we have today, it's related to sustainable housing. So we have very interesting presentations today. But first of all, I would like to mention that this event is organized in the context of EHPA flagship event, the Heat Pump Forum, that will take place tomorrow. Unfortunately, it's sold out in person. However, you can still register for the online, for the online version, let's say. So I invite you all, if you have the time tomorrow, it's going to be full of presentations, very, very interesting presentations. And our Secretary General, Thomas Novak, that is here today, will tell you more about it later. So in our agenda today, we have, as I mentioned, very interesting presentations and the keynote speech by our Secretary General. And let's start with this. First of all, some housekeeping rules. If you have a question, you can use the chat. I suggest you that you put the name of the person you're directing the question to. So like this, the person can know. And then in the Q&A session, we can ask the questions accordingly. So this webinar is being recorded. So afterwards, after the event, we will edit it a bit, and then we will share it in our YouTube channel, social media, and of course, we will send a copy to each one of you attendees. So don't worry about it. Just be patient if you want to recheck it again. So without further ado, I would like to introduce our Secretary General, Thomas Novak. He's a long-term renewable energy aficionado, and he owns his own heat pump. And he's also, as I mentioned, the Secretary General of the EHPA. So Thomas, whenever you want, the floor is yours.
Thank you, Irene. Sometimes secretary, sometimes general, as I like to say. So the slides should come up. Keynote speech is a big word. I hope that I can really unlock a little bit of the understanding of what we think heat pumps can do in Europe's building sector. We are often hearing that 80% of the buildings that we will inhabit in 2050 are already here. So the renovation sector requires our utmost attention. And I'm happy to say that over the past 5 years, we have enough technological progress that makes us believe that this sector is ready for heat pump deployment. And in other words, it's ready for decarbonization. On the good news side, factual tidbit, I just heard yesterday that our office building in Brussels will be renovated, at least the heating system will be renovated, and it will receive bigger heat pumps for more capacity. With a tear in my eyes, it will also still have a gas connection, but they say they couldn't do it quickly enough and they need the gas for backup. So let's hope that the heat pump are dimensioned sufficiently big in order to make them make the fossil fuels eventually redundant. I will switch to my next slide. Can you just confirm that it's also switching on your side? I had some problems in the past with that. Irene,
it is switching on my side.
Very good. The EHPA is a sector organization that represents all kinds of heat pumps. While we are discussing today heat pumps in renovation buildings, it's quite interesting to see that we can cater to this segment by two angles. We can, on the one hand, put an individual heat pump into an old housing. We can, on the other hand, connect this old house to a district heating, or what I like to call it, the last district heating generation, the ambient loops, energy grids that operate at ambient temperature and that are powered by heat pumps, or can provide heat as a source into an individual building. So it's actually three options that we have: a big central heat pump, an ambient loop that is connected to many small heat pumps, or a separate heat pump into the renovation building. We're also looking at industrial applications, and for this specific matter of big buildings, I also added this picture of St. John's Tower in London, where the question could be, is this heat pump in an individual building, or is that a district heating system that is just turned from horizontal to vertical? I'm also really fond of the smaller heat pumps that are used in white goods and electric vehicles, because they open the door for people to understand that they are all using heat pumps already. The trend, I think, is going to have 4 heat pumps in one building. But let's look at the markets altogether. Are we ready? Do we have enough heat pumps that can be sold and installed into this building segment that we want to look at today, the renovation sector? This is data that is not making any distinctions. So you see here that the heat pump market all in all has grown tremendously over the last 10, 15 years, and that we have achieved an incredible, really outstanding growth of 34% in 2021. Preliminary data for 2022 gives us a value of 28% now. This is for the comparison between first half of 2022 and first half of 2021. Normally, we know that the third and fourth quarter are getting more stronger. But with the supply situation that we have, I wouldn't dare to make such a statement today. Anyways, what we see is that the heat pump markets are growing despite very difficult conditions, and I will come to that at the end of this presentation. The European Commission has said we should double annual sales by a factor of 2 by 2025, 2026, and that would mean that we will arrive at around 4.6 million units in 2025. Of course, a challenge that needs to be catered. A few numbers. The total building stock of heat pumps in 2021 has contributed significantly to the provision of useful energy, replacing fossil oil and gas, has done so by integrating renewable energy. I will not read all the numbers. You can read them on the slide yourself if that finds your liking. But the important message here is heat pumps are replacing fossil energy. Heat pumps are doing so by integrating renewable energy. If we move to 100% green electric grids, this would even be fully emission-free solutions. That's what I have at my house. I have a green electricity tariff, I have a heat pump, and I have even photovoltaics. So in a net perspective, my house is completely energy positive. Of course, it has to use the grid in order to achieve this. And the really nice advantage is heat pumps do not create emissions at the point of operations, and by doing so, they also save particulate matter emissions and 45.9 megatons of CO2 emissions. What is not so known normally is that heat pumps could also provide quite some demand-side flexibility potential, and by doing so, help stabilize electric grids and help increase the utilization factor of green electricity in these grids. Is this enough? Well, I just said doubling the whole thing by 2025 or 2026 is needed, and doubling it another time by 2029, 2030. That's the result of what the European Commission has proposed as Repower EU, an additional 10 million units to be sold by 2026, an additional 30 million units to be sold by 2030. These are hydronic systems, and we think as EHPA that air-to-air heat pumps have a similar impact on the replacement of fossil energy, so that they should be considered at the same time. And here you see in the light blue is the air-to-air heat pumps that should grow at the same speed. Good. Are we moving fast enough? Because this looks all really, really nice, right? You probably agree that this is an industry that is in a growth mode, that it's an industry that is worth looking at. But unfortunately, if we put all this into the context of all overall energy demand for heating, then we see that we are not on track with regards to the European targets. Here you see what has happened in the past from the introduction of the first Renewable Energy Directive via the introduction of the second Renewable Energy Directive, and now we are discussing and finalizing the third Renewable Energy Directive to come into force in 2023, of course with some delays of transposing, but statistics shows us that we are not moving fast enough, and I think that's also an aspect shared by everybody in the building sector. Either technology replacement or renovation or both is not happening at the necessary speed. But you could say, well, that's just because these heat pumps are not ready for the renovation sector. And here I brought a few examples for you to understand. And I think my colleagues later, Nora and Sophia and Robin and Daniel, they will give you much more insight. both in terms of projects and in terms of what has been done already. Everything that I'm showing you today is real today. So here you find an example of a nice heat pump, air-to-water unit monoblock that is used quite successfully in the like-for-like replacement of old buildings. It's indeed true that also the building on the right side, an old water mill in the UK, has been renovated without doing a lot of renovation activities on the building envelope. And that's really the thing that we need to take into consideration. The heat pumps work in renovation. Sometimes you have to renovate, where you have to do more for the building envelope. Sometimes you don't. The master number is 55 degrees centigrade. If your building can run at 55 degrees centigrade, it's in principle ready for immediate heat pump replacement. I will not talk much about super homes in Ireland. It's now called all electric island super homes. I'm a big fan of this. I think this is really the blueprint for everything that we should do to make it easy for end users to renovate their houses, get support on the design side, get support on the technology choice side, get support on financing. And if I understand correctly, you even get a technical check once the heat pump is installed, so that you as an end user can be sure that what you're buying is delivering as promised. So very, very good thing. Very happy to have you here, Robin, afterwards and listening to that. Some other examples, these are really only exemplary. I think it's important to put pictures in the brains of people to say, look, if you see such a building, can that be done with a heat pump? Yes, it can. Water-based heat pump here in Amsterdam, in the Netherlands. On the right side, you see an air-to-air heat pump that is used in Vancouver. So these are all typical buildings that you find representations of the variety in the building stock that can be done with heat pumps. We have made some booklets about that, heat pumps in renovation. You can find them on our website. One example, the one from the title page, it's a social housing concept project, and I think that's also important. We should renovate social housing first. That helps to increase the market, and it helps to be careful with government resources, because eventually, if social housing is inefficient, we as all taxpayers will pay the bill afterwards. So it would be a very honorable cause to renovate social housing with low emission technology, ideally with heat pumps and photovoltaic, to make them not only energy efficient, but also energy affordable in the future. Here you see just a few numbers. It's actually quite an old system. It still uses refrigerant R407C. That is no longer typical, but it has an efficiency of 4 and heating capacity 38.4 kilowatts. So you see also there is bigger heat pumps that can be used for these type of buildings. Another example, high rises. Typically, people say, yeah, high rises don't work. Then you need gas because of central heat production, etc., etc. But here you see that you can do something else. You can put small heat batteries into each apartment, connect them with heat pumps, and provide renewable energy for these type of buildings. And the last example from Austria, multifamily building that is using this type of decentral provision. You have a central heat source and you have several mini heat pumps. Some other people call them booster heat pumps, but the important thing here is that you put them on the apartment level. Depending on the design, you can even put cooling services into the apartment. You connect them to a hot water tank, so everything that is needed in the apartment is provided on the apartment level, and then there is a loop that goes through the building, which then you could call a district heating, if you could call the building a district, that is providing heating and cooling at the same time. So back to the numbers, we are looking at are we selling enough of these units? And here you see that we have done a capacity split across Europe, and most of the heat pumps that we count in our statistics are of smaller capacity. So we do not really know where the big heat pumps are installed, because for the statistics it's difficult to understand if a 20 kilowatt heat pump is used for renovation of a building or is it just an extensive new building. There we have to improve our own data situation. But we know that about 10% of the heat pumps sold in Europe are of a capacity of more than 20 kilowatts. That would still mean that it's around 150, 200,000 units that are used in renovation already today. We expect this number to increase, and we will increase the data stability. That's the same number, just aggregated. So you see again that most heat pumps are in the up to 20 kilowatts capacity, and then smaller numbers only above that. So I think I have made sufficiently clear that we think that we can renovate buildings with heat pumps, but we do think that also the speed of this change is not fast enough. So we call for what we call a heat pump accelerator. That's what the whole conference tomorrow will be about, different angles on how to speed up market development, how to ready the value chain for mass deployment of heat pumps. And mass deployment for me really means a near to complete replacement of heating systems with heat pumps and an increase in the market at the same time. And in order to do that, we think that we need 5 steps. The policymakers need to create trust in market actors so that they invest in heat pump technology, both on the construction side, on the manufacturing side, but also at the end user and then across all application areas. In order to do so, it is of utmost importance that the cleanest heating solution is also the economically most attractive one, and that can be done by addressing taxation, by introducing subsidies, and by banning fossil subsidies. We will probably hear something from the Council very shortly. I've seen very interesting proposals that are currently discussed on a technology transition alliance or an additional package for renewable energy promotion as the currently, in addition to the currently discussed papers that are done to solve the energy crisis. And then step number 3 would be we need a lighter hand on legislation. That's something we discuss with the European Commission at the moment, because we see that quite a few of these requirements are also slowing things down, if it's only in making processes more lengthy. And then, of course, we need skills. That's something that I think in the short term can be handled, because all the heating installers can also become heat pump installers. But eventually, if we want to have photovoltaic on every roof and every commercial building, and if we want heat pumps there, then it means also that from 2024, 2025, we need more, really higher number of skilled people. And obviously, we also want to increase the application envelope of heat pumps and integrated systems by R&D. And all of this needs to be done with while checking also the grids, because this is electric technology. So we want to upgrade the electric grid to avoid that they break. One word on these grids, I will not say much about it. I think the grids have always changed and have always been adapted to changing demand. We can do that at the same time, and we should really stress that this is necessary but possible. And with that, yeah, this one I can just leave because I think I'm running out of time. I would like to conclude. We can renovate buildings. We need high ambition in order to do so, but this high ambition needs concrete action. And we think that we need an all hands on deck approach. So all of you are invited to watch this space, to talk to EHPA, to help us to set this heat pump accelerator into motion. The association has now 173 members. If you like what you have heard so far and you like the other things that we do, then please consider joining. End of advertising block. Thank you very much, and I wish you a good rest of this webinar. I'm really looking forward to hearing from Nora, Sophia, Robin, and Daniel, and thanks for Irene for aptly moderating and setting everything up.
Let's see if you can see me again. Thank you very much, Thomas, for your presentation. Actually, we have a question for you, so don't disconnect. Wait a second. Like, the question is on the chat, and basically Daniel asks us, is the heat pump manufacturing capacity ready to double the produced units until 2025? Yeah,
we think yes. I was skeptical in the beginning. I have talked to a lot of people. I will talk to a few CEOs again today, and the overarching message that you can have is that the CEOs think they can manage the value chain if the framework conditions are beneficial. Meaning, if legislation puts heat pumps in a positive light with the requirements that I just said, long-term trust. So we should not create the impression that if this war in Ukraine is ever over shortly, then we just jump back to cheap oil and gas. But it's not really a replacement question of Russian oil and gas. It's a replacement option of all fossil energy, and that needs to continue for climate reasons, not so much for the cost reasons at the moment. So if that is done, and if for the end user, it makes economic sense to invest into heat pumps, so that it's not only happening when you get subsidies, then this demand will trigger supply on the manufacturer's side. And what we see today is increased investment in European manufacturing plants, total investment that we could oversee. We did a recent press evaluation is 3.5 billion euros that are invested until 2025. And you see more and more that also components and parts are manufactured here to avoid the value chain challenges that we see currently with Asia.
Thank you, Thomas. We have actually time for another question, and in the chat there's another one, and it mentions, it's by Matthias Hemmersbach, and it mentions, do you have figures on the current share of heat pump application, new builds and renovation?
Well, that's basically what I tried to show. Maybe I didn't make that clear enough. So good question indeed, Matthias. We do not have a proper distinction. We only separate by capacity. And as I said, the capacity is not necessarily an indicator for new and renovation, because in a very new building, in a very energy efficient single family house, you would have capacity needs between 4 and 6 kilowatts. If you renovate a multifamily building, that could, and if this could also be the energy demand of 4 apartments. So let's say a new 4 apartment building would have an energy demand of about 14 to 18 kilowatts. But if you renovate an old building, this can be exactly the same capacity. So I cannot conclude from selling a 16 kilowatt, 14 kilowatt, 18 kilowatt heat pump that this is an old building that is renovated or a new 4-family building or maybe a more luxurious double family building. So we don't have that. And then I see, and I just to be time efficient, I see that there's the other question on the slide 14. Yes, we do have a market report that is in its final steps now, and that's the basis of everything I've said so far. So you can access the market data on our website, and it's free for members, and it's available for purchase for everybody else.
So, thank you very much, Thomas, for your presentation and for answering the questions. Again, if you have more questions, you can just put them in the chat. Just include the name of the speaker. So maybe like during the webinar, like the speaker can answer the questions. And now it's time that we start with the presentations of today. I hope you can see the presentation. So our first speaker today is Nora Ganzinelli. Nora works as a project manager and a business developer in the business development team on the Energy and Mobility division of Rene Consulting. The team is specialized in proposal writing, coordination, and technical management of R&D projects, mainly Horizon Europe. She's working in the Sunhorizon project, in which she assists in the management and coordination. And she will speak about it today. So Nora, whenever you want, the floor is yours.
Thank you. Thanks. Thank you for your presentation and for introducing me. And today I want to present the Sunhorizon project and show you an overview of this project. Well, I'm trying to go to the next slide, but I'm not able to that.
Like you should be there's an option right up that says take control. If you click there, you should be able to pass the slides. If it doesn't work, don't worry, I will pass the slides for you. So just let me know. Can you see it
by yourself?
Okay, sure, no problem. I will just move to the next slide.
Well, thank you. The project Sunhorizon is a sun-coupled innovative heat pumps is a project born from the Horizon 2020 program of the European Union. And as mentioned before, I followed as project manager on behalf of Rena Consulting the project. And it is a pleasure for me take a couple of minutes to present my company. Please, next slide. Well, Rena Groups provide certification, testing, inspection, and consulting services across energy, mobility, marine, industry, certification, and infrastructure sectors. Rena has more than 2,000 offices in 70 countries and is composed by 4,000 employees. Now, I'm working in the energy mobility department, and we can move on the next slide. The heat pump and solar appliances are the most social accepted residential renewable energy based on energy systems. And Sunhorizon will demonstrate up to TRL7 innovative and reliable heat pump solutions. This kind of heat pump, acting properly coupled and managed with advanced solar panel, can provide heating and cooling to different kind of buildings and to achieve a lower emission, lower energy bills, and lower fossil fuel dependency. To do so, we can go to the next slide. Were developed several technology packages with the aim of covering at least the 80% of the heating and cooling needs of renovated building and other different kind of buildings, such as a new, single, multi, and tertiary buildings. Where, here we can see all the members of the consortium. Sorry for the noise, but today in the office there are a lot of problems. We can see all the members of the consortium, which is composed by 5 top-level academic polytechnic institutions, 12 industrial partners, 5 large enterprises, 7 small and medium enterprises, and 4 association and stakeholders acting as a demo site. Well, regarding Sunhorizon demo sites, we can go to the next slide, and we can see, please, the next. Well, we can see the geographical location of the 7 different demo sites. And of course, for each kind of demo sites, a different solution has been studied and has been applied. And the approach, of course, depends on the characteristics of the buildings and the geographical location. In particular, the demo sites are located in Berlin, Nuremberg, Sant Cugat, and Madrid, Cluj-Napoca, and Riga. Well, we can move on the next slide, and we can go to check all the technology used during this project, and the demo site needs, in particular, space cooling and space heating. Of course, the demo sites needs are supplied with 5 different technology combinations. But if we move on the next slides, we can start to see concretely the application. I want to show you the solution applied to the 3 different cases. The first one is the demo site of Riga, which is composed by 2 small residential single houses. The demo site in Madrid, that is a social housing apartment block. And the last one, also in Spain, Sant Cugat, is the demo. This demo is a tertiary civic center. Well, on the next slide, we can see the first demo situated in Riga. As I mentioned before, is composed by 2 small residential houses of new construction. We can see the pictures of both the houses on the right, Imanta and Sunisi. And here on the left, we can see the data consumption before Sunhorizon. Well, pre-Sunhorizon, on the 2 houses were installed a gas boiler for domestic hot water and a radiator and underfloor heating for the space intake. On the bottom part of this slide, we can see what kind of technology packages was applied. The specific needs in this case were space heating, domestic hot water, and electricity production for building application. In this case, was applied a TP2, technology package 2, and this kind of technology package consists of a boosted heat pump coupled with the dual sun photovoltaic thermal panels and a ratio-term storage tank. In particular, thanks to the boosted technology, that is a gas-driven thermal compression heat pump with boiler, we can solve the need of space heating and domestic water. And the hybrid solar photovoltaic thermal panel assist the heat pump and give electricity production for building appliances. But not only for building appliances, also for the storage system and the residential electricity for smart energy electrical heater. Well, moving on the next slide, we can see an overview of the installation of TP2, which is applied in Riga. On this slide, we can see the specific case of Imanta, and we can see the installation of the internal and external unit of the technologies used. And on the next slide, we can see the same photos also for the Sunisi house. Okay, on the next slide, I reported the user interface for the photovoltaic thermal panel installed on the two houses. And the nominal production value are reported for both the buildings, for Sunisi and for Imanta respectively. And below is shown the energy production in a week. Well, on the next slide, we can see a pictures of a building. This picture is referred to the demo site in Madrid. That is a large residential social housing apartment block. And compared to the previous houses, here we have a very large building with 10 apartments. Well, on the left, we can see reported the consumption before refitting and before, of course, Sunhorizon. And we can see also that each flat had your individual appliance. I'm speaking about a gas boiler supply domestic hot water and a space heating through a radiator circuit and higher split for the cooling needs. In this specific case, we decide, and we can see on the next slide, to apply the technology package 4, which consists in the parallel integration of renovable heat pump of BDR for space heating, for cooling, and for domestic water. And the heat pump is assisted with the photovoltaic thermal panels of dual sun that also cover the heat demand and the electricity demand, for example, to cover building appliances electricity consumption. And well, if we move on the next slide, we can see the two pictures of the building in Madrid. And I want to put in focus that are applied also as a passive renovation actions in this kind of building. And for example, to introduce the external insulation and also to insulate the roof with an integration of insulating layer. And is applied also a substitution of the windows for or the wall building. Well, on the next slide, we can see the first step that is that we apply during the project. We can see the roof with the preparation of the surface and the pre-installation of the technology package used in this case. And also on the next slide, we can see the buildings before the installation, during the phase of pre-installation. And after that, on the next slide, we can see all the equipment that was connected to the pre-installation and the commissioning. Well, here we can see the real technology implemented in this demo site, and on the next slide, we can see another overview of all this kind of technology. And after that, I want to show you on the next slide an overview of the energy efficiency impact that we can calculate. For example, the GHG saving, which is around the 71%, and a non-renewable primary energy saving of 87%. Yes, well, in this slide we can see properly the comparison between between the pre-Sunhorizon and the post-Sunhorizon situation. On the next slide, we have the third and final type of building that I want to show you today, and is a tertiary civic center. A building with a large area and attended by a lot of people every day. And here we can see what they used for space heating and cooling and for the domestic hot water before Sunhorizon. And we can see also what has been introduced thanks to the Sunhorizon project. On this specific case, we used a technology package 3, which consists in coupling the photovoltaic thermal panel of dual sun with the chiller system on Fahrenheit. And well, on the next slide, we can see the scheme of this plant. All the position and the connection of all the technologies. And on the next slide, I reported also a replication photo, a real photo of the technologies and of the demo sites. And also on the next slide, we have another important point to put in focus, because from this data, we can understand how big is this building and how big the needs are in this case. And we have an overview of how many people frequent the building in one day and the services that they offers every day. So from what time to what time must remain open, and also therefore how long the plant must remain in operation, in action. And if we go to the next slide, we can see that we can see on the next slide that thanks to the app, we can this kind of app allows users to view real-time information about their buildings' indoor climate and energy consumption through the installation, of course, of sensors in different rooms. For example, in this case, in 10 rooms of the building. And if we move on the next slide, we can see the conclusion of my presentation. We can see 3 different types of buildings, and let's go to discover the possible replication potential of the technology package used in Sunhorizon. Of course, through the 3 different demo sites, Riga, Madrid, and San Cugat. Riga is applicable for single houses with a natural gas connection, and this measure is suitable for new renovated building, and is applicable in all kind of climate zone. The TP used in Madrid, the second case that I showed you before is suitable in case of residential and tertiary building both for new and renovated building, and is suitable in a sunny climate zone. Regarding sun demo sites, the technology package used in this case it's okay for medium scale tertiary building and in the residential building, and it's okay also for new and renovated buildings, and but only for also in this case for a sunny climate. Well, on the next slide, I reported my contacts. And if you want to find out more about Sunhorizon, you can contact me or you can join us and visit us on the official website of Sunhorizon. Thank you.
Thank you very much, Nora, for your presentation. It's time that we move on to the next one, that it's by Sophia Lettenbichler. Sophia works as a European Public Affairs Officer at EIT InnoEnergy, leading the public affairs work on topics such as sustainable cities, buildings, energy efficiency, hydrogen, and energy for circular economy. EIT is the innovation engine for sustainable energy across Europe, supported by the European Institute of Innovation and Technology. Sophia has 8 years of experience in Brussels, and she has been working in various roles on innovation, sustainable energy, and digitalization policy. So whenever you're ready, Sophia, you can take control of the screen. Of course, if you can't, don't worry, I will take over.
Thank you so much, Irene. Good morning, everyone. Thanks for the nice introduction. I believe indeed that I can switch the slides. So if you can see my first slide now, everything should be fine.
We can see it. Thank you.
Perfect. All right. So my presentation is not going to be about projects. What I'm going to do with you today is to introduce you to EIT InnoEnergy and more specifically on what our activities are in sustainable cities, buildings, and energy efficiency. So for those who are not familiar with EIT InnoEnergy, we're a European public-private partnership co-funded by the European Union directly from the European Institute of Innovation and Technology. But we are set up as a company that basically acts as a private investor in startups and scale-ups, meaning that we invest at very early stage innovations, and we are the most active investor in Europe in the energy sector. We have a pan-European footprint. Just to mention, we are also active in the US, and of course, we also have international projects going on. But we have offices all over Europe with around 200 employees that support the startups in various ways, and we can go a bit more into details on this later on. Currently, we have 300 startups in our portfolio, working, as I said, all in the sustainable energy innovation sector. But we also have activities, for example, on education. We have master's programs, we have professional learning programs, because skills, as we know, are very important also for innovators and startups. And I also would like to mention that one of our core activities are actually industrial value chains. So we have been creating the European Battery Alliance and leading the industrial arm of it. We are operating the European Green Hydrogen Acceleration Center. And we are also active with the European Solar Initiative to basically reshore PV manufacturing in Europe, just to give you some highlights. As I said, I would like to give you a bit of context first, because it explains a bit better the startups we're supporting in the sector of sustainable cities, buildings, and energy efficiency. So let's dive right into it. I don't think I have to mention to many of you, but as you know, the built environment is a very important economic sector in Europe. It is 9% of the EU GDP. It represents 18 million direct jobs. And as we also know, it's a big energy consumer, especially now facing this winter, 36% of direct energy use and also 37% of CO2 emissions. So built environment, as all of us know, is a really, really major part of the energy transition. And I also would like to give you a bit more context of how we are operating now, because obviously, as I said, I work for an investment company, so we have to take into account the environment we are operating in. We see that there is increased climate consciousness, I would say even more in the last couple of weeks, of consumers, but also corporates to actively drive the energy transition, so a pretty good sign. At the same time, we also have some governments, especially in Europe and I would say in the US, that take really ambitious actions currently. So we, of course, have the EU Green Deal. Part of this is Fit for 55 also. And I think the US Inflation Reduction Act is also really increasing the pace of the energy transition. At the same time, we are facing an energy price crisis. The inflation is at a historic high, and also building materials prices are soaring. And at the same time, we have an issue with skills shortages, not just in the construction sector, but you know, also for installers and so on. So quite a complex background. Let me give you some more market insights on smart cities and buildings and energy efficiency as well. This is a pretty dense slide, so don't worry about the numbers. What I want to tell you is that the building stock that we have currently, as you might know, 90% of it will still be existing in 2050. And the not energy efficient buildings also tend to rely heavily on fossil fuels. So if we want to make the energy transition happen, of course, we have to work on energy efficiency and renovations. And then, of course, also take into account the fuel switch. And as I said, because 90% of the buildings that we see now will still be in use in 2050, there's just no way around. Yeah, we have to work on energy efficiency and the built environment and the building envelopes as well. The building sector in general has increased energy efficiency in the past years, but there is a trend that it actually has slowed down in the last couple of years. So in the, let's say from 2014 to 2020. The key reasons for that is that there's unfortunately actually less spending in R&D compared to other sectors. There is low venture capital investments, and I can also explain a little bit with you later why, because of course we operate there. And the fragmented, there's also quite some fragmentation in the sector, which means there is limited innovation happening and also limited technology integration capabilities. Now, why are the renovation rates also lagging behind? I already started to hint at some of those, but it's actually pretty complex. Let me just pick out some of the reasons here, because also this is a pretty dense slide. From a building owner's perspective, of course, there is, for example, high upfront costs that you're facing. There is lack of access to capital, and we also know that there's quite some uncaptured value still in the energy efficiency improvements. Or, for example, when we look at knowledge and information, we also notice that there is usually not enough information and support available, and also quite some low awareness. When we look, for example, at the value chain actors, also there we know, as I already said, we have a lack of skilled personnel and training, quite some low quality auditing, also depending a bit on the member states. And in general, also the bureaucracy is not easy. And as we know, there is fragmented regulation happening throughout the member states, and also limited actually grant schemes and governmental programs. So just to give you some reasons, there's some more on the slides, but you can go through that afterwards. But let me also give you some more key trends that we see. In general, we believe that cities and districts will become more sustainable and greener. There is a focus on smart and sustainable infrastructure design. And by the way, that's also one of the investment trends, everything in digitalization. And green planning of public spaces and also the adoption of circular models are becoming more and more relevant. So as I said, for example, one of the key trends that we see is circular economy, also in the renovation sector. We also have this concept of the 15-minute city approaching, and in general, just sustainable and green infrastructure. Yeah. Now, I said I gave you some key trends. The next slides are basically EIT InnoEnergy's footprint in this sector, where I wanted to highlight some of the companies that we are supporting. And for the sustainable cities and buildings sector, we actually have 4 different trends that where we see our investments happening. And I also gave some examples of the companies that we have in our portfolio. You see there are quite a lot, so this is quite promising. We have one segment in sustainable cities, which basically tries to optimize the flow of energy in general, and also enabling accessible and livable cities. Then we have some companies in the construction and renovation sector, and I will speak about, I think, 2 of them later on a bit more in details. We have a specific focus also on distributed clean energy systems, because we believe that on-site generation and self-consumption, and of course heat pumps are a big part of that, are also very important to make the transition happen. So it's not just the renovations, but also the on-site generation of buildings themselves. And the 4th one is sustainable buildings in general, so maximizing the energy efficiency and the sustainability level in general, also, of course, for the indoor air quality. And let me give you the same overview for energy efficiency. Well, we call this for industry, but actually the innovations we have, they also work for buildings or commercial buildings. We have one segment more in the monitoring and analytics, so the software and the sensors sector. And then we have also energy efficiency equipment and electrification solutions in our portfolio. One of them I will also, or actually 2 of them, I think I will present to you in a minute. All right, so as I said, I just wanted to pick out some of the companies that we're supporting currently, so you better understand our portfolio and the innovations that we're happening. The flagship one, of course, that I want to show to you today is a heat pump. It's an energy efficiency heat pump that operates at 100 to 150 degrees. It's specifically designed for industrial applications, but also works for district heating systems. And well, it's a really innovative solution that basically uses no F-gases and flammable refrigerants. Then the next company that I have picked out for you is heat storage. This one is also more geared towards industrial applications, but it can also work, of course, in district heating schemes. And I think Thomas already explained a bit more on that. So this one works for waste heat recovery for temperatures between 200 and 1000 degrees. Pretty interesting, as I said, as it's very efficient and there's almost no thermal loss per day. The next company that I would like to introduce is called CEO. So it's called Cloud Energy Optimizer, one of the smart energy management systems in our portfolio. It's basically a cloud-based add-on that you can put in your building energy management system, and it with the weather forecast and different energy needs of the building, you can basically optimize the energy flows, and you have cost reductions of around 10 to 50% per building, which I think is pretty impressive. Then another company, as I already mentioned, is Wind My Roof. So this one is an on-site production, especially for high-rise buildings. You mount basically a small wind turbine on the roof, and with the thermal winds that are generated in these valleys between high-rise buildings, you generate wind power. And the electricity produced can also be integrated with solar panels, so you have basically double on-site production happening. And finally, let me move to a turnkey solution called Evo House. So this one is an autarkic house that basically has all of the innovations in it. It's very efficient. It is self-consuming, so there are also PV panels installed. It works with heat pumps, and it includes the active participation of inhabitants. So you also have basically your prosumers involved in the energy transition. And this house is near zero energy, so you can classify it as an autarkic residential district, actually. And finally, as I also mentioned, we have quite a big focus on building refurbishments, as we believe that this is still one of the key areas where Europe is lagging behind. And actually, one of the most complex ones is the refurbishment of condominiums, so apartment buildings. And we have one company that operates currently in Spain with a one-stop shop solution for building refurbishments that basically does it for a whole apartment building, and it offers a solution from A to Z, from financing to applying for subsidies, but also all the technical solutions. So any renovations and refurbishments your building needs, but even also on-site production is included. And I think that's a pretty interesting way to spur the current renovation wave. So something to be also discussed, I think, in the upcoming regulatory discussions. And with that, I also leave you my contact details in case you're interested to learn more about EIT InnoEnergy and some of our other portfolio companies, for example, and looking forward to the discussion.
So thank you very much, Sophia, for this very interesting presentation. Now I'm just taking control of the screen, and it will be the time for Robin O'Mara to present. Robin is the Chief Marketing Officer at Electric Ireland Superhomes. She has more than 20 years of experience in marketing. She began her marketing career in Eircom as a sales representative, and then she moved to the banking industry to go back in the end to Eircom that was transformed into Air. She joined ESB Group and Electric Ireland back in 2016 and has managed a number of strategic communication projects since then. And now, Robin, whenever you're ready, the floor is yours.
Thank you, Irene. Sorry for my voice. I have a little bit of a cough. So yes, I joined Electric Ireland Superhomes about 2 months now, so go easy on my questions. I'm still learning, but I have been with Electric Ireland for over 7 years, which leads me to this brand and how we came about. So Electric Ireland Superhomes was formed about 16 months ago. This is a joint venture between Tipperary Energy Agency and Electric Ireland, and the Electric Ireland Superhomes brand was formed there. Our target is 35,000 homes by 2030. And this is part of an overall, I suppose, country initiative as well, where the government has a target of 500,000 homes to be retrofitted by 2030. So it's a huge ambition for our brand, but for our country as well. So it's an exciting time for us. Electric Ireland, I suppose just a bit about Electric Ireland. They are the largest utility in Ireland. They have about 1.2 million customers. That's about 50% market share in Ireland, and they have I suppose their ambition is all around clean energy and decarbonisation. Tipperary Energy Agency have been in this game for about 5 years. They're 30% of the market, so they have been they're a very important partner in this, and then obviously the brand has come together. So Electric Ireland Superhomes has been formed, as I said, about 16 months ago. I think the last time we were in presenting, it was about 4 months ago, so we were just a year old. So our mission is that we empower customers to achieve warmer, healthier, low carbon homes. And in order to do that, you'll see on the right there, we have a very ambitious target. It's famously called internally the hockey stick, because the figures look like a hockey stick. So in our first year, we were looking at 100 homes. We're hoping to double that this year. It'll be trebled next year. And then you can see for yourself the targets that go up. And in order to do that, we need to scale the business quite quickly. So in order to do that, we have one central office at the moment. We need to grow that to 4. We have about nearing 35 staff members. We need to grow that to over 200. Included in that, you need to invest in your IT, your digital systems, marketing, which is the area that I cover, sales, HR, regulatory, finance, and obviously our stakeholders. So that's just the operational element of it. Contractors are a huge piece of this. Without them, we can't run the business. So we need to develop that, and we need to develop the skills and knowledge in that area. And then obviously at the other side of that is consumers, because we need to grow awareness of what we do, and I'll get into that now in a minute. And then, there's a lot of regulation around this, and trying to get an understanding of what it is we do and how that applies to the customer. There's a lot of information, a lot of technical jargon that people don't understand. A lot of people here will be used to the jargon, but consumers don't understand that. So it's how do you build up that education and awareness? There are in Ireland a lot of grants towards getting your house retrofitted, and then there's a financial gap, but I'll come on to that later on. So our one-stop shop model, how we operate is, first of all, we need to build that awareness that I was talking about, and that knowledge, and build the expertise, and provide that education to homeowners. From there, it will go into our sales team, and we have a very, very skilled sales team that will take you through a very in-depth, I suppose, analysis of your house and what you need. And from there, we build out energy reports. And like our design that we would build, it has to be a minimum of a B2. And obviously it's we're a fossil fuel. We're not in the business of, if you want to change your gas, but like if you want to keep your gas boiler or any fossil fuel, that is not the area that we're in. We won't accept homes with that. It has to be sustainable. So we are only about heat pumps when it comes to heating your home. So that's very, very important. Quality control is hugely important, and I'll come on to that a little bit later as part of the programme. Advocacy is obviously huge for us as well, about educating and engaging. That's a massive area for the one-stop shop model. And then there is a ton of paperwork and a ton of work that needs to be done by our finance team that kind of tops and tails the whole process and takes all that admin away from the customer. So that's how the one-stop shop is model is run internally. So what exactly is a super home? I've kind of alluded to this already, but I suppose we have a number of measures that we would look at in the home. It's a minimum of a B2 that we're looking at. So we only want to work with the heat pump. Obviously, there's solar involved in that. We're looking for air tightness. It could be new windows, new doors, insulation in your attic, solar PV, hot water. So it's all of those encompassing parts that makes up a super home. And as I said, it has to be a minimum of a B2, and we do not work with fossil fuels. So this will be very familiar to you, but this is, I suppose, what we show our customers in terms of what the fabric and the measures that we're looking at. So these are the insulation, air tightness, ventilation, heat pump, and obviously solar PV is optional, but it's something we would certainly be pushing. And it's actually an area that's hugely growing in Ireland, and there's a lot of interest in that. So why I'm here today is to talk really about the Super Homes 2030 project. This project was, I suppose, developed before the Electric Ireland Super Homes brand was born. So it would have been run by our partners TEA, the Tipperary Energy Agency. So it's a 3-year program. We're in year 2 of 3. So there's about 1 million of funding in that. So it is, as you can see there, there's loads of partners that are crucial to this. So Tipperary Energy Agency, LIT, which is now the technology, it's rebranded to TUS, so it's Technology of the Shannon, or University of the Shannon, sorry. So they're a very key partner in this program in terms of education and even down to recruitment of engineers and the skilled people that we need. So they're a massive partner. Obviously yourselves, the EHPA, Sustainability Works, huge piece around finance, and finance is a massive area for this, and I'll come on to that in a little bit. ESB, we're an initial partner there around the technology. So they will be a very influential partner, and then obviously ourselves. So we're trying to build up all of these different work packages, which I will go through in detail. So there's 7 different work packages. Obviously at the very, very top, there's the coordination and the project management. Then we get into work package 2 there, which is the market analysis and building the brand. So this would have been all around the Electric Ireland Superhomes brand and how we build that out, trademarking, everything from awareness right down to trademarking. Then we have work package 3, which is obviously all around standards and capacity in buildings. So and then the Superhomes financial solutions and the customer journey. On the customer journey side, that is a huge area for us, where we're investing in technology internally, just to, I suppose, build out. While we had 100 homes retrofitted last year, we're going to double that this year. We need to treble that, and then, as I referred to that hockey stick, we need to build that, invest in those journeys now, and building out tools that will support our engineers, that will support the marketing teams, the finance teams, every touch point within the organization. So it's a huge work packet for us. Then we have work pack 6, which is development and expansion and exploitation. So this is around, I suppose, building out contractors to come on board, not to be looking at kind of new builds. This is a country-wide project. This isn't just in major cities. So we're looking at probably a 20-year project plan. So it's how do you build and get those local contractors throughout Ireland, not just in the major cities, as I said before. So it's building out that. And then on work package 7, that's dissemination and communication. So that's all around our marketing, and I'll come on to that in a bit more detail next. So the market and the brand, obviously we've built out a huge website, and we're trying to build on that in terms of education, not just consumer, but also to contractors. But building that out through all of the channels that we can use and leverage off, our parent brands in Electric Ireland, which is the main supply brand in Ireland. And then obviously going to different trade shows. We've a lot of PR activity. We have been known and called on by a lot of different radio stations throughout Ireland, because heat pumps are quite topical in our country at the moment, because I suppose that we're now talking about when do you stop using gas boilers, when do you stop using oil. So heat pumps are definitely trending here in Ireland. And obviously we're looking at different advertising campaigns, different sponsorships. We're about to go to an event in Ireland called Ideal Homes, which is literally a huge event that looks at everything down from furnishing your home to retrofitting your home. So it's a 3-day event. So we're getting into things like that, trying to get our brand and our that awareness out. Operational quality system. This is hugely important in this program. yes, it's easy to look at this now when you've just completed 100 homes, but what when you get a few years on, when you get to kind of 6,000, 8,000 homes, this is hugely important that we get this right, that we have the right resources, the right customer care, being able to handle the queries, different continuous improvements and audits and technical checks, and making sure that we do both internal and external audits. So it's hugely important for the quality and for the reputation of the business. So this is a very, very important part. Just then, I suppose some learnings on what's going on for us. Like quality is a huge thing for our customers. Decision making it's extremely important. They're putting in so much money into this, and money and the finance element of this is a huge, I suppose, gap. We get grants up to about 40 to 50% maybe of the measures that you need to put into your home. Some customers don't have that money to hand. It could be coming from savings. So we are in the process of launching a couple of different initiatives with a few banks and credit unions in Ireland, and that will only grow as we're looking to, build that out with Sustainability Works in terms of getting, I suppose, a better loan that can be actually tied to your mortgage, which is lower mortgage rates. Right now, the personal lending market will be a little bit higher than your mortgage lending rates. So that's a huge, I suppose, barrier to entry for customers. So that is an area that we are really, really investing in and looking at. End-to-end process, minimize the paperwork for customers. So that's the beauty of a one-stop shop. You have to be a registered one-stop shop to avail of this. We have about 12 one-stop shops and probably another 12 coming on board this year. But that's as I said, the beauty of the one-stop shop is that we handle everything for you. So we will manage the grant. We take we will take the grant in for you, and you only pay the balance. So that is all done by our internal teams, our finance teams, and our operational teams. From our contractors' point of view, I suppose it's building that network and building that knowledge, getting access to contractors, and providing that pipeline of work for them. So in Ireland, resources are scarce. So we need to build on that, and I suppose partnering with LIT and TUS, it's hugely important for us, and getting access to those coming out of college. And then obviously cash flow and paperwork, as I mentioned before. And the map on the right is just some of the areas that we've completed this year. From a government point of view, then, our public policy is very supportive. We have a multi-annual scheme, so there's no closing date. They're investing 8 billion to 2030 in this through the SAI grant scheme. And that's the scheme that I was mentioning. There's about 40 to 50% that they will fund. The cost, as I mentioned, is quite high. When Stephen, our managing director, was here back in June, he would have said that the average cost of a retrofit was about 50,000. That has risen to 60, and some would argue that it's gone a little bit higher, and that's down to increased cost of materials. Capacity constraints. We have a lot of capacity constraints here in Ireland, getting access to surveyors. So building energy BR assessors. So we can't get access to them at the moment. We're struggling, and that's down to the cost of living crisis here in Ireland. So people are trying to fix their mortgage rates and availing of different mortgage offers that provide a lower rate if your house has got a really high energy rating. So a lot of people are calling on those BER assessors to come out and reevaluate their houses. So that's having a knock-on effect on us, because it's crucial to the one-stop shop process, in that you need a pre-BR before you start the work, and then you need a post-BR, and we can't actually close that I suppose retrofit until that post PR is done. So that's just one example. There's many other examples of, you know, contractor issues and supply of materials, doors, windows. They're taking twice as long as they used to. We do have a huge ambition just around automation and digital within the business, so we're heavily investing there. And as I mentioned there, the cost of supply chain issues. But it's all good progress. We've huge ambitions, and it's a great brand. And yeah, hope to be here again, showing more work that we've done. And thank you for your time.
Thank you very much, Roman, for your presentation. I'm just gonna share the screen again because for some reason it closed, but don't worry, we'll be back in an instant. So in the meantime, I would like to start introducing our next presenter, Daniel Carbone. Daniel was born near Barcelona. He studied thermomechanical engineering at the Polytechnical University of Catalunya, where he also conducted his PhD on the field of computational fluid dynamics. He is currently leading the team of thermal systems and modeling at the Institute for Solar Technology, SPF, where he has worked since 10 years. SPF is the largest institute from the Eastern Switzerland University of Applied Sciences, OST, which has been created 2 years ago by merging 3 existing universities located in Rapperswil, St. Gallen, and Bourges. I hope that was the correct pronunciation of the places. Now, in a second, Danny, I will give you, I will share the correct slides, and if you let me know if you can take control. If not, I will just, oh, perfect, it works. But maybe you have to move further because for some reason you're in the first slide at the beginning of everything.
Yeah, I see in my presentation, I see, or it's slow maybe.
Yeah, 1 second. If not, I'm gonna take control again. I'm sorry everyone for the technical problems. We live, we learn. In a second, we will have Danny's presentation, I promise. Okay, just let me take back the control so I can just put the correct slide for you. Because for some reason it was not working. Just give me a second. Now, let me know if you can take control and you go to your correct slide. No, it's not working. You will have to try and pass it manually to slide 69. I'm not sure if you can see the options below with all the little slides. I hope you do because it's easier. If not, don't worry. I will just let me know and I will pass the slides for you.
I see it. So now it should be the first slide.
Yeah, now we are on the first slide of the slide deck. If not, don't worry. I will just take control and I will share the screen myself, and you can let me know when I have to pass the slides. Does that work for you? I know it's not ideal, but
so I didn't get it. You are not seeing the presentation, or it's not an okay? So then you pass it on for me. Yeah.
I think just 1 second. Again, sorry for this technical inconvenience. In a second, we will have the presentation. I promise. We are not living without hearing Daniel's presentation. So let me know if you can see your slide with your face, your name. Okay, so I'm gonna pass the next slide.
Okay, then you move. Okay, you do it. Good. So yeah, thanks Irene for the presentation, and good morning everyone. So I will present the project 3HP, which stands for 3 generation systems based on heat pumps with natural refrigerants and multiple renewable sources. I already did this presentation, part of it is not the same, in June on a EHPA workshop. So some of you might have seen this, and I'm sorry for that. I think I still can make it interesting for you too. So Irene, you can go to the next slide. So basically, 3HP it's a European H2020 project. It's a research project, quite technological based, where we are supposed, and we are achieving this, to move technologies from TRL 3 to 5. It's a project of about 5 million euros that started in 2019 and will end next year. February next year. So we are at the very end phase of the project, and here you can see the logos of the consortium that is here. Maybe next slide. So the main goal of 3HP. Irene, next. Thanks. So the main goal of 3HP is to develop systems that are based on electrically driven natural refrigerant heat pumps coupled with photovoltaics. And the systems are aiming to provide heating, cooling, and electricity. That's why we call them 3-generation systems. And we are targeting multifamily residential buildings. So at the proposal phase, and we are achieving these measurable targets, we set up some numbers. We said we are going to reach 80% of renewable on-site share with a net zero energy concept. So we produce as much as we consume, but we need to exchange 20% with the grid because we are using heat pumps. And our main goal was to develop systems that would have a cost reduction, and this is already on the investment of it, from 10 to 15% compared to current heat pump technologies that would have the same efficiency. So of course, we cannot compare to heat pumps that are performing worse than we achieve here, and we are always aiming at SPF, so seasonal performance factor, or COP of the complete system above 4. And this would lead to 75% of greenhouse gas emission reductions compared to traditional technologies. Next slide. So in THP, we are aiming to develop two main systems. One is what is called a dual sourcing system. So basically, I mean, all heat pump developments are centered into the heat pump and to the refrigerant cycle and into the heat exchangers inside. And in this dual source sink system, it's a system with a reversible heat pump that can provide heating and active cooling. So it's fully really reversible. And the innovation here is that it has an evaporator and condenser, which is dual source sink, that can use both groundwater or water, can come also from wastewater or from solar collectors, and air as direct heat sources and sinks for the heat pump. That's the main innovation. And the idea is, if you compare with ground source, if you have the opportunity to have air too, you can have the same efficiency, reducing the borehole length by a factor of 2, which will reduce the investment cost by at least 15%. Now, all system includes also the electrical part, photovoltaics, battery, and household electricity, and everything is managed by an advanced energy management system, which is basically a model predictive control that does a 24 hours forecast and decides when to operate the heat pump, which sources to use, and how to discharge all the storages, both electrical and thermal. The next system, shown in the next slide, it's what is called a Solarized Lorry system. That's a particular case of a Solarized system, which is a system targeting Central European climates where heating demands are dominant and when there is still enough sun. So the Solarized system is the system where the heat pump, where we also focusing our developments, are using solar thermal collectors as a heat source. And as you can imagine, at night or in cloudy weeks in Central Europe, there is not enough solar energy for it. So then we need another heat source for the evaporator of the heat pump, and this is a water storage. This water storage will be converted into ice in winter from December to February because of size reasons, and can be easily regenerated with solar energy because it has a sink of 0 degrees. The innovation that we bring in 3HP is that we don't use a conventional ice storage, but an ice slurry storage with a supercooling technology, which is what I'm going to explain later on. And everything is controlled also like before with an advanced energy management system. So in the next slide, I would like to explain you a little bit what is our concept of ice slurry production. The reason why we use ice slurry is because we can reduce massively the cost of the storage when we don't need heat exchangers on it. So an ice slurry storage is a storage that there is only water and a slurry in, so water and water crystals, but there is no heat exchangers. This reduces massively the cost. And the way to achieve this in an efficient way is to use a supercooling method, which the idea is you take water, you cool it down below the melting point. You see the graph here. I don't have a cursor, but you can follow this. So then we decrease water below 0 degrees in a supercooled state. That's a metastable liquid form. And we keep cooling this until we trigger nucleation, crystallization, in a device that we call crystallizer. So we basically pass water supercooled into a crystallizer, and we induce nucleation. And at the end of the crystallizer, we have water at 0 degrees with a slurry on it. So some part of the water has been converted into solid particles. Then everything is at 0 degrees. And the difference between the melting temperature and the actual crystallization is what is called supercooling degree. And the higher the supercooling degree, the higher the probability of freezing. So in order to have a stable supercooling degree, we have developed materials, isophobic coatings that can delay the formation of ice, and we have applied this into real heat exchangers, brazed heat exchangers that are used in heat pumps as an evaporator. Now, in the next slide, we show how these isophobic coatings worked. Irene, next slide. And we can see that I'm not going into the details. Results are published in this publication of the International Journal of Refrigeration. So what you can see is on the graph, you see the outlet temperature on the supercooler. So here we applied different coatings into these heat exchangers, and we tested them. These heat exchangers, we tested up to 6 kilowatt power. And the reference one, on the bottom, you see the names. The ref means reference. This is an untreated heat exchanger. And then we have different names of coatings, not going into details. Important is that the best coatings can improve the supercooling degree by 40%, which means we can use this in very stable form. Now, these heat exchangers are being currently tested on heat pumps, and as I will explain later. Now, another innovation of the project, it's also on a heat exchanger for a refrigerant cycle. Irene, if you can go into the next slide. So in the project, we are using two natural refrigerants, propane, using the dual sourcing, and also in the ice lorry. But in the ice lorry, we also use another system with a CO2 heat pump. CO2 heat pump, we are targeting new buildings where the domestic hot water share is higher, and propane is targeting more refurbished buildings where the share of space heating is larger. Now, for those, I guess most of you are aware of it. When we work in CO2 with a transcritical cycle, when we reject heat, so in the typical condenser, we have a gas cooler, so CO2 is not condensing. It's on gas state, which means it has a very large temperature difference. As you can see in the red line here, it goes from 70, 80, up to 20. And this is very good for domestic hot water, but it's not good for space heating because we need a large delta T. Now, what NTNU has developed is what is called a tripartite gas cooler. So basically, in these heat exchangers, you see on the bottom part, it's what we are using for preheating water. So in the graph on the left, you can see the blue line going from 10 to maybe 30 degrees. Then we go in with another heat exchanger that is in the middle one for space heating. This is heating water from 30 to 35. And then the last heat exchanger is taking the domestic hot water preheated, and it's reheating it from 35 to 60, 70 degrees. And with this, the efficiency of the heat pump for space heating and domestic hot water, it's very high, and we can use it also for space heating applications. Also here you can see also the publication on the experiments of this tripartite gas cooler. Now, in the next slide, so we develop materials, we applied these coatings into heat exchangers. We use this as an evaporator. We have developed this tripartite gas cooler, and now there is a heat pump that combines all of this. It's a CO2 heat pump in the power range of 10 kilowatt for residential applications. And this is a power control heat pump with a flooded evaporator, and it uses also Jector technology, and it uses this tripartite gas cooler that I showed before for space heating and domestic hot water, and also the evaporator with supercooling. So this heat pump has been built by Heim, a company in Switzerland, and we have been testing this at our institute. And in the next slide, we can see some of the results. So here are results of the COP, the coefficients of performance in a steady state conditions for parallel mode. So we are testing domestic hot water and space heating simultaneously. So we provide both. For space heating in this testing campaign, it's 30-35 degrees. And for domestic hot water, we tested different points. You can see in blue, it's 1055, and in red, it's 1070. So we can reach very high temperatures on the domestic hot water side. And if we look at the normal 1055, so 10 is the inlet into the cold water, and 55 is what we provide as domestic hot water, we can see that when the evaporator temperature on the water side, so T evap in means water inlet, it's 5 degrees. The COP, it's above 4.7. which is very good. And also very interesting, we can see conditions at 0 degrees. So in these conditions, water was entering at 0 degrees and was leaving the supercooler, the evaporator, at -2 degrees. It was stable, no freezing, and we can achieve very high performance there. We can see that for 1055 degrees domestic hot water, the COP was above 4.2. And also you can see in this slide a link to a publication we did for a propane heat pump. We also did the same for a propane heat pump, and we tested it, but I cannot show it here. You can go into this publication. Next slide, please, Irene. Now, the other system is this dual sourcing, and the methodology was very similar. This was developed by Tecnalia. Tecnalia developed a heat exchanger that would be a dual source and dual sink for heating and for cooling, where the main innovation is this heat exchanger has a direct contact with water and with air. I mean, the refrigerant of the heat exchanger, because there are systems on the market that use an indirect loop with brine, but of course, efficiency it's penalized. And here it's a coaxial concept, where in the annulus you have the refrigerant, inside you have water, and outside you have fins, and then water, air, it's blown. So you have a direct exchange with both. So they tested, they developed this, they designed it, tested it as a single unit on a heat exchanger. Then they applied this into a heat pump, that's a propane heat pump, where you can see here, and this heat pump has been tested, and now it's been tested on a system test that I'm going to explain later. And here you also have two publications that you can look for the results of this testing of the heat exchanger and of the propane heat pump as a unit. Next slide, please. And the two systems we have developed, both of them have this advanced energy management system. So that, as I said before, that's a model predictive control. So that the system does 24 hours forecast and then decides what is the best operation condition now. And on simulation framework, we have tested this with our real system, with the systems we are testing now, and we can see that the efficiency, the cost reduction, because we are using variable electricity prices, is in the range of 10 to 15%, depends on the system and the conditions. And this has been shown on simulations. You can also see the results that has been published. And now this advanced energy management system is tested together with the complete system in our labs with a system test. So next slide, Irina. So what we are doing now, because we are at the end phase of the project, so we started from materials, we went to heat exchangers, we went to heat pumps, and now we go to systems. And the way to test the systems, it's what we call hardware in the loop dynamic test. So basically, it's a system test in which we test consecutively several days. We do it in 6, where these 6 days represent the whole year. So they are selected in a way that when we test continuously the system for 6 days, we know the efficiency of the system on a year. And these 6 days represent, of course, different times of the season. And in this system test, what we have, for example, in this graph, we have the gray part. This is what is simulated and emulated. So we don't install everything. We just install what we develop and what we need to test. The rest is emulated and simulated. For example, solar thermal collectors, the PV modules, the domestic hot water tapping, the household electricity, the space heating demand with the building. All this is simulated in a simulation environment, and then it's emulated. So we convert the results of the simulation into real boundary conditions for our system that we test physically there. That includes, for example, a heat pump, all thermal storages, this advanced energy management system, or rule-based control, the battery, inverter, and so on and so forth. Also, the ice lorry could be there, but in particular, in our case, this is also part, is emulated and simulated. And if you go to the next slide, Irene, so this is how it looks like now the current system test at SPF. We are testing now the CO2 heat pump with this ice lorry part, where the ice lorry is emulated and simulated. You see it in the blue box in the middle. That's the emulation of the slurry. Then on the left, you see the storage tanks, the domestic hot water space heating with a freshwater module for domestic hot water. There is a recirculation because it's a multifamily building, and there is all the hydraulics and all the controls. And on the left, you see also the home battery and inverter. So this system operates autonomously for different days, and it receives relevant boundary conditions that would represent reality. So we can bring the system to TRL 5 or 6, depends on what are we testing. So on the heat pump, we will get 6. On the ice lorry, because we are not testing it, we don't get to this level. And this system is tested now at SPF for the ICE Lorry CO2 and at IREC in Catalonia for the dual source sink. And in 3rd of November, we will have a dissemination workshop in Switzerland, where we are going to show after the workshop the system test and how it operates. So if anyone from you is in Switzerland and would like to attend, contact me. And at the 3rd of November, you can visit our labs. And last slide. I mean, that's the last slide, but it's not less important. We did a lot of work on technology acceptance, where we were trying to understand and improve the stakeholders' acceptance on these kind of systems. We wanted to analyze and identify a bit the interests and what would be the needs of key stakeholders that would have a decision-making process. So we started with qualitative interviews in 4 countries, and with this feedback, then we did organized stakeholder workshops where we would get the feedback with the same people we interviewed before on these workshops, and the results of this were very interesting, and you can see them in 2 public deliverables that I have placed here. So you can go there and look, because it's quite dense, but I think it's quite interesting. So that's it. Thanks very much for the presentation, for listening the presentation. Here you have the link of the website, and also a link to the Zenodo place where we put all public deliverables that are of interest for the audience. So thank you very much.
Thank you very much, Danny, for your presentation. Despite the technical problems, we managed to make it. So now it's actually the turn for your questions. So audience, if you have any question, please write it in the chat and we will try to give an answer to them. But in the meantime, I have some questions for you guys. So Danny, since you were speaking just right now, and you mentioned that you were using the dual heat pump for heating and cooling, can this concept be used for heating dominated climates?
Yes, it can. I mean, in the project, we kind of split it in a way that this would be for South European, where you have heating and cooling needs. And the reason there is you need to have both, because otherwise you don't operate the system enough hours in the year. But if you go to Central Europe, where it's heating dominated, you can use the same concept, and there is enough heating demand hours that this would compensate. So ground source is very much spread in, for example, in Switzerland. So this could be also a system that can be used Central Europe and even North Europe.
Okay, thank you, Danny, for that quick answer. I would like to just now move and ask Nora, because you were presenting Sunhorizon, the current demo sites and so on. So I wanted to ask you, how do you see the future? So what could be the future development of the project? What would you say to me?
Yes, thanks for the questions. Well, thanks to the relevant industrial players and leveraging preliminary market analysis and demo activities, I mean, Sunhorizon is strongly oriented toward possible future scenarios. And Sunhorizon aimed at unlocking the potential for a mass customized solution based on an optimized design and combination of existing innovative technologies. And the proposed technology packages aim at covering at least the 80% of the heating and cooling needs for different kind of buildings, as we can see during my presentation.
Okay, thank you for your answer. Since we're talking about projects, futures, and challenges, Robin, I would like to ask you, I mean, I'm familiar with super homes because I'm lucky enough to be also part of it from EHPA side. But I would like to ask you, what do you think is the biggest challenge super homes has as of now from a marketing standpoint?
Yeah, it's funny. I've been in marketing for over 20 years, and I've never seen the level of demand. So that's probably the biggest challenge. It's trying to meet the demand and the expectations of customers, but doing it slowly, that scales, that is at the same pace as the business is able. So overloading our sales team or our contractors is obviously not where anybody wants to be, working way over the hours that they need to be working. So that's probably the biggest challenge from a marketing point of view. So it's managing demand and expectations. And then the second thing is, and I alluded to it in my presentation, is just around education, and on getting consumers to understand the language. Like, the language here today is very technical. So how do you dumb that down for a consumer? And I don't mean that in a disrespectful way, but make it understandable. We have all sorts of phrases like net zero, carbon neutral, like there's loads of phrases out there, but do customers actually understand what that means? And how do you make it more accessible to everyone, to understand what they need to do for their home and the environment? So I would say demand and education.
Thank you very much for your answer. And yeah, it makes total sense. Like, without the knowledge, it's difficult to move forward. So today we had like 3 project presentations and a presentation that was not a project. So Sophia, as you can imagine, the next question is for you. So I would like to ask you, in which projects, companies, or type of projects or companies is InnoEnergy currently investing or is looking to invest in?
Yeah, thanks a lot, Irene. I have trouble turning on my camera, so bear with me, please.
No problem.
I think it's working. Okay. Indeed, we are not a project. I would say, if you now look at what we have seen presented, it's Horizon Europe Innovation Actions or Research Innovation Actions. We are operating as soon as these innovations are coming to the market. And usually our sweet spot as EIT InnoEnergy is in the pre-seed financing for all the, let's say, financial experts here. That means that usually we come in at the very early stage of a company that is just in the beginning of entering the market. And the reason is that we have so much expertise of the last 10, 12 years in supporting companies in exactly that stage, in building, for example, the team, in knowing in which markets they should first go to, but also, for example, product development and so on, that this is really where we can make the most difference.
We have a question in the chat. What is, for you, Sophia, actually? So what is the process for a company to get help by InnoEnergy?
Well, I don't like the word help because we don't help companies. We are a company ourselves, we're an investor. So if there is, of course, an overlap in our strategy to invest in your company, and as I just explained, if you're at the right phase, so early seed financing, then we would be happy to have a conversation with you. We don't have funding or financing rounds open. We basically operate on a rolling basis, so you can always contact us if you have a great idea or an innovation that is coming to the market. In a way, I also want to mention that we do company building. So even if you, let's say, work for maybe an incumbent or a big company, a utility, or maybe even a heat pump producer, and you have a great idea, but you need other partners, we are also interested in looking into that. So I hope that answers your question.
I hope so too. We actually have another question, this time for Danielle, by Omar Montero Dominguez. Omar asks if it's possible to use PAC CO2 for space heating, because usually they operate with a large delta T.
So this is what I showed. This tripartite gas cooler is designed specifically for this, because it has 3 heat exchangers, and 2 heat exchangers are for domestic hot water, preheating and reheating, and the middle part is for space heating. So then you use the whole temperature difference on the gas cooler very efficiently. When you cannot do this because your domestic hot water is fully charged, then you can operate only on a space heating, but then the efficiency it's lower. Still, it can operate it. So we have tested it and we are using it in this way. But when we like try to use it in parallel to improve the efficiency of the heat pump.
I see Omar has said things, so I'm guessing that has answered his question. I don't see any more questions from the audience. As I said, this is like your last chance to please provide us with a question. If not, like I will have to close this webinar earlier than expected. So, if you have your questions, we can wait. Like in the meantime, like I would actually would like to ask to Danny, like since you were speaking, and I think like your presentation was actually very like, since you were having technical problems, I'm compensating in this way. I'm sorry, like that's how it goes. Your like your technology, let's say it's like super cooling technology, right? So could it be applied for other cooling applications as well?
Yeah, so at our institute, we come from the heating market because we are in a heating dominated climate. And we have been using ice storages for heating applications, kind of an innovation since many, many years, more than a decade. So we come from this, but actually for an ice lorry, this is a niche market. So what we are developing can be used for cooling, for residential cooling and peak load shifting, and in industrial processes where they need a high capacity storage for cooling. So we are moving from heating, and now we will start to look also for to apply this into cooling applications where the market is way bigger than the heating actually for this.
Okay, that's very nice actually. Then I would like to ask Robin, like currently, like the Irish government has like I don't know exactly when that happened, but I know that there's like series of targets that you have to achieve, like 25% of homes retrofitted with heat pumps by 2030. Do you agree with that target? Do you think that is possible? And what do you think are the main barriers to achieve that?
Yeah, it definitely is possible. I mean, as I said, there's 12 one-stop shops out there, and soon that will double. So, we're definitely moving in the right direction. We're at 35,000 of that 500,000. So, we've a long road ahead of us. And I suppose the biggest challenge is probably around all the fabric contractors, all the surveyors that we need, the skills. There's a skills gap. The government have invested in trying to, I suppose, attract those trades back into the country. So we are looking outside of Ireland as well for engineers, and so that's probably the biggest challenge, is actually ramping up the people to actually mobilize this is probably the biggest challenge. Yeah.
Definitely. Well, thank you for answering. And from like, let's say, Irish government to like European EU scenario, I would like to ask you, Nora, what can the Sunhorizon project to this current EU energy scenario that we are experiencing as of now?
Well, considering that buildings are responsible for the 40% of European Union energy consumption, and heating and cooling are the 51% of the total energy demand, the objective of the project of Sunhorizon include the development or replication studies in promising markets around Europe. And the idea is to contribute to the conversation to renewable energy technologies, making them more accessible and user-friendly toward the 60% on CO2 saving and the 40% of domestic energy bill cut.
Okay. Thank you very much for your answer. And then again, we're talking about projects, but it's time to ask also Sophia. And I have one last question for you, and I think this will be the last question, unless, of course, the audience has something else to say. That, as I said, you still have time to ask your questions. Sophia, I would like to ask you, where do you see the investment trends in the built environment? since we were mentioning buildings like a minute ago.
Yes, thanks a lot. Yes, indeed. Interesting question, because I think that also should give some hints to some of the projects, because in the end we cannot just operate with grants. I think what we also see in the rollout of solutions is that we will need private capital massively in the future. And what the current trends are actually is that we see investments mostly going into IoT solutions, monitoring, data intelligence, especially in the sustainable cities segment, but also looking, for example, what I described before in the distributed clean energy one, it's platform-oriented services, systemic solutions that integrate basically different technologies via digital solutions. And the same goes if you look at sustainable buildings. So, for example, we see big investments in smart thermostats or smart device property management platforms and so on. So I think that's also a hint for the audience. This is where the private capital is currently going, and where venture capital companies see the future of, and also the big changes and the big markets developing for the energy systems.
Thank you very much. I don't see more questions from the audience, so I think maybe it's the time to close this webinar. I, of course, want to thank you all for being here today and for your interesting presentations. It's always nice to learn. Like, as I said, some of them I already knew what they were about, I have to say. But like, it's always nice to learn from you all and your work. And I think it's a very valuable thing for our audience, the ones that were here and the ones that might and for sure will watch the webinar afterwards when we make it public. So thank you for coming today. I would like to ask you if you like this event or you would like to learn more about our events. You can just stay connected with us. You can follow us on our social media, check our website, subscribe to our newsletter. We are quite active. And yeah, once again, I want to wish you all a great day. Thank you for coming. And as I mentioned, the recording and like the presentations will be available very soon. So thank you very much, and I wish you a lovely day.